Hey, welcome back people, Gary Simmons here, and in this lesson we are going to continue to create our attack system. This is lesson 29 of the Game Institute's Dead Earth series, and in the last lesson we had began to write our attack system. We had set up this animation layer in Jill's animator that allowed us to trigger randomly any of these attack sequences just by having our code set the attack parameter in the animator to a value between 1 and 100. And it worked pretty well. We saw Jill running up to the player, and when it gets within range of the player's melee trigger, it launches one of these attack animations. And of course, the attack layer also has a mask that masks off the lower body parts so that our attack layer doesn't mess around or interfere with any locomotion that might be happening on the base layer. And we utilized this in the attack state. If I call up Jill's area entity game object and make sure that I unfold her attack state, you will see that we allowed ourselves to specify a speed. And in the attack state, this is of course set as the speed parameter of our animator, just like every other state does. And of course, because the animation layer that contains the attacks only affect the top half of Jill's skeleton, by setting the speed we are triggering our usual walk, jog, sprint or idle based on the speed that we set. So our zombie is able to walk and run towards the player whilst also launching an attack animation with her top half. And we need her to do this because if we just stop Jill when she enters her melee trigger, it's going to become very easy for the player to just simply step back and move outside of the zombie's melee range, and then that's going to trigger the zombie to go from, on her bottom half at least, from an idle animation into one of the locomotion animations. And of course all of these transitions take time, and we need to make sure that the zombie doesn't spend most of its time just trying to recorrect its speed, transitioning between idle and walk, idle and walk, idle and walk, like so, because all the player has to do in those situations just keep stepping back a little bit, and the zombie will drop back into some sort of idle pose, then into a walk pose, and you get the idea. And the other reason we don't want to do this is because we want Zombie Jill to be as close to the player as possible. We want their body colliders to be touching, so she's right up in our face, and when she's launching all of those attacks, we know that she's not too far out, that the colliders that we're going to eventually add to her arms and her mouth are going to intersect our body collider, and we'll be able to register damage. And you know, that all works already. If I make sure that I set Zombie Jill's speed to, let's say, 1, so that when she's in the attack state, she's gonna, once she's in our melee range, keep walking towards the player, so she's always trying to keep her body butted up against the player. You'll see that when we're playing it, it kind of looks really good until we look down at her feet, and that's when the whole thing goes, you know, a little bit Pete Tong, a little bit wrong, because it looks great like this, and it's like, hey, yeah, she's rotating to face us because we have that code in our animation state, but look at her legs. That doesn't look good at all, does it? And we've got some other problems as well. The whole point of the attack state is that when she's attacking us, as we move, it's not too easy to shake Jill off, and that's why we keep her continually rotating to face the players. Otherwise I'd just be able to jump behind her like that too easily. She'd go into the attack state and I'm off and away before she has a chance to really do any damage to me. But we have another problem as well. If I set the speed of our attack to 0, then obviously this is going to trigger on the base layer the idle state on her bottom half. And this looks much better. That stops all the feet sliding, and it looks much better. But here's the problem. So there you go. But look, she's also no longer as close to me. And if I can actually nudge myself back from her such that she's still intersecting my melee trigger, but you know, she's not really making contact with my body at this point, and therefore, look, that would look ridiculous. When she's doing that feeding animation, she wants to be right up in my face, perhaps even closer than that. So it makes it very easy for us to step back from a zombie, and then all of her attacks are missing us. But there is, of course, another problem here, and I'm just showing you how easy it is to get outside of a field of view. Because remember, our attack state has this line of code in it that says, if we're not using root rotation, then as the player moves, rotate Zombie Jill to face the player. But of course she's not doing that. You can see she's dropping back into the alerted state and having to do that lengthy seek to find us. So why is that? Well, it's obvious, right? Because on our idle state, we have a root motion configurator. because we want our idle state to use root rotation and root motion. That's how the idle state looks best. And of course we don't get any problem in our walk, jog or sprint states, because in these locomotion states we have root motion configuration scripts that set the root rotation to 0, because when we're walking, running or jogging, we absolutely want our script to be rotating Zombie Jill on the spot to face her steering target. So what's happening when we set a speed of 0 as the attack speed, we have a few problems. The first one of course being that on the base layer Zombie Idle is activated, which turns on root rotation, and if I call up our attack script and scroll down to its update function, you can see that pretty much everything that we do with respect to rotating the player is wrapped within this conditional if we are not using root rotation. So if we want our zombie to kind of rotate on the spot to face us even when her legs aren't moving, when she's in idle, well then we need to turn off that root motion, or in fact any root motion that might be playing on the base layer. And that's pretty easy to do. We can just add root motion configurator scripts to each of our attack animations that make sure that any root motion requests underneath are turned off. So I'll do this by adding a root motion configurator to each of my states. I'm starting with attack 1, and what I'm going to do here is I'm going to set root rotation to -10, okay? And that's going to make sure that we cancel anything out that might be requesting root rotation underneath it. Now at the moment, obviously a simple -1 would suffice, because we have a zombie idle animation which simply increments the root rotation reference count by 1. Therefore, -1 would turn it off on the layer above it. But you're also going to see later on that we're actually going to insert additional layers between the base layer and the attack layer. 2 of them actually. Actually, I think might even be 3 of them. And they may all have animations that are also requesting root motion or root rotation. So what we're going to say is, look, we're just going to set it to -10, which is going to pretty much blank out any root rotation requests underneath it while this animation is playing. And we don't have to mess around with the root position. We can leave that at 0, meaning that we don't want to change it. If the animation underneath it is requesting root position, then let it use that. It doesn't affect our attack animations. So I'm basically going to add that same script now with the same root rotation of -10 to all of my animation states, like so. And we're nearly done. So exactly the same added to all of those root motion configurators. -10 in the root rotation field. Of course, we don't wish to add one to our empty state, because the empty state is the state that is going to be playing on this layer when we're not attacking. So we don't want to put anything on this state that's going to alter the default behavior on the base layer. So on the base layer, if the zombie idle state and the turn left and right states want to use root rotation, which they do, but the locomotion states don't want to use root rotation, all is well. Our empty state on the layer above it will not interfere with that in any way. So if I press play now, you'll see that even if we set Zombie Jill's speed to 0, which we have in our attack state, such that it is the zombie idle state on the base layer that's being transitioned to, we're not going to be able to easily shake her off just by dodging left and right. She will actually rotate to face us. There you go, she's still attacking us there, look, see? Great, isn't it? Now, obviously, that means we get a little bit of foot sliding if we look down at her feet because she's rotating on the spot. But you know what? This is just one of those choices that we have to make. We could decide to use root rotation, but that basically means that Jill's feet are going to be planted on the spot, and the only way she's going to be able to line up with you if you dodge quickly to the left or the right is to play a seeking left or seeking right animation. That's pretty slow, and with the transition as well that takes a little bit of time, it just becomes too easy for the player to sort of just dodge out of the way and shake off the zombie. But of course, if you have different animations that react much more quickly, or maybe you're even using a 2D blend tree with root rotation for all of your locomotion, then you wouldn't have to do this step. But like I said, with the animations that we have, it's more important to me that the zombie is harder to shake off, because let's face it, most of the time when we're playing, we're not going to be looking down at the zombie's feet, are we? Okay, so problem 1 is solved. What we're basically doing is making sure on the attack layer we switch off any root rotation request so that these little code blocks here and here in our attack state continually rotate Zombie Jill to face the player. Oh yes. But of course, we don't really want Zombie Jill to drop down to the idle state unless she's very close up to our player, because even with this new system, you can see it still allows me to move myself back a little bit, such that she's still within my melee trigger, so she still stays in the attack state, but she's not actually close enough to me now to do any damage. So what we need to do is we need to say we want Jill to drop into the idle state. In other words, we don't want her legs to be moving, but only when she's right up against us. So even if we're in the attack state and we're launching an attack animation, we want one of these walking or jogging or sprinting animations to be making her legs, keeping her running towards us, unless we detect that she's so close to us now that we can safely drop back into the idle state on the bottom half of her skeleton. Now, there might be a number of ways that you think we could do this, and I got to be honest, the first thing that I thought of doing, which didn't work, was to say let's just put a extra function that handles collision interaction to Jill's state machine. So we could basically have an on collision enter function, or an on-collision stay function, or however you want to implement it, that is basically polling for a collision between her collider and the FPS controller's collider. And we could say in our attack state, if I set the speed to 2 for example, we could say if our colliders are not touching, then set the speed in the animator to 2. Otherwise, if they are touching, set the speed back to 0. And we know, obviously, that in our animator, that would be setting this parameter between 0 and the speed we specify, which would be making her go to idle when the colliders are touching, and whatever speed we specify for the walk, jog, or sprint when there's a little bit of slack space between the zombie Jill and the character controller. Now, the reason we can't do that is because Jill's rigid body is a kinematic rigid body. We need it to be. We can't have the physics system trying to alter the position of Jill's transform. We have to allow the navigation system to drive Jill's transform. If we made Jill's rigid body non-kinematic, we would have a race condition. Both the physics system and the navigation system would be trying to alter the position and the rotation of Jill's transform. So, of course, we have to make her kinematic. Problem is, the same is also true of our FPS controller rig. The character controller behind the scenes is also like a kinematic rigid body, and therefore these two colliders cannot generate collision messages between each other. Unity doesn't support it. You can't have two kinematic rigid bodies colliding and generating notifications. You can have a kinematic rigid body colliding with a non-kinematic rigid body, or two non-kinematic rigid bodies colliding with each other, but Unity doesn't support generating collision or trigger tests between two kinematic rigid bodies. So we're screwed there. We can't use that system. So the other thing that I thought I could do was say, hey, well, there's bound to be some mechanism within the navigation system that says, how can I detect when Jill's nav agent, remember, if we select Jill in the hierarchy, we can see that her nav agent is represented in the world as this sort of cylinder. So I thought there would be some mechanism in the system where I could check if Jill's navigation object, her cylinder, is intersecting or touching our navigation obstacle. Because remember, our FPS controller also has a nav mesh obstacle on it. Where is it? There it is, that thin little thing here. But guess what? No such luck. So what I thought instead is, well, why don't I automate this by saying, let's take the radius of Jill's nav agent and the radius of the FPS controller nav mesh obstacle, because that gives me essentially the distance between them. And once the distance between Zombie Jill and the FPS controller is smaller than the combined radii of both those navigation objects, then we can say, well, they're touching or almost touching. However, I can't really do that, because when we measure the distance between them, we're not really measuring from the same point. You know, the pivot point of Zombie Jill might be situated such that the direct line between Zombie Jill's transform and our transform is a diagonal line, which would be much longer than the combined radii. So what I'm going to do instead is I am going just to create a new variable in our attack state that allows us just to tweak it on a per zombie basis, and it's just simply going to be a distance, the distance at which Zombie Jill will drop back to not trying to walk towards the player anymore. And really, we just need to test this. And the nice thing about it is, although it's a little bit manual and we have to test it on a per zombie type basis, it does mean that it works with NPCs of all different size. So what I'm going to do is, in our attack script, I'm going to create a new serializable variable, and I think I'm going to put it at the top here underneath the speed, and I'm going to call this stopping distance. I'm not going to make it a slider because, you know, I don't really know what the valid ranges are, so I don't want to limit us to an arbitrarily low range, just in case in the future we want to deal with a really big object. And I think I'll just set this to, I don't know, 1.0 by default. But like I said, we'll have to test it. Okay, so what we need to do now is rather than just set the speed in the onEnter state function, we need to sort of basically do something like this. We need to say a vector3 distance, and we will pass in our zombie state machine's position and the current target position. So in other words, if the distance between zombie Jill and the target that she's heading towards is smaller than our stopping distance, then we will set the zombie state machine's speed to 0, which of course will also pass that 0 in as the speed parameter in our animator. Else we'll just set it to the speed that we specify in the inspector. So you can see now in our inspector, we for our attack state, we now have that stopping distance parameter. So let's see what happens. Okay, so as you can see, she's still trying to walk into me, and that's clearly because that distance of 1 is not baggy enough. So let's try 1.3, maybe. We want to take baby steps because we want to get it as exact as possible. There you go. So she stopped, but then when I move forward, her legs run towards me. And you can see that keeps her butted up. So is there any movement there? Is there any movement there? If there is a bit of movement there, then I might be able to. I'll try 1.2. All right. I want to take this. I want to take this as close to the edge as I can, as close to the wire as I can, so that we keep Zombie Jill butted up against us at all times. Dare I try 1.1? I think I'm going to have pushed my luck with 1.1. I got to be honest. Yeah, I pushed it. I took it too far. I knew I would. So let's just check that works okay with the walk speed as well. Because obviously when we're doing a jog or a run, she's going to naturally, by the time she stops her animation, be kind of butted up against us anyway. No, that kind of works pretty good. So really the only compromise that we've made here, and it's one that I'm going to have to live with, is the fact that, you know, when she's actually stopped, she rotates on the spot. There's not a lot we can really do about that. Perfect. I also have changed my mind a little bit about the speed of that transition from walk to jog. Remember we altered it in the last lesson and we set it to something like, I don't know, was it 2 seconds? I don't like it. I think I'm going to set it down to 1 second. 2 seconds is way too long. I saw too much foot sliding. Now, I know we're kind of, you know, we're doing this test in a way that, you know, we're kind of looking at her feet the entire time she's attacking. There you go. That's better. That's better. There was too much sliding as the animation and the root motion was being blended between walk and jog. 2 seconds, far too long. And I think I'm going to set the attack state speed to 2, the jog. I think that's a better one. I think that's going to keep the zombie much more in our face. And of course what we've also done on our attack layer is we've added that root motion configuration script, so that even if our zombie is in the idle state on the bottom half of her body, one here, which uses root rotation, we cancel out that root rotation and say, hey, during this attack, we don't care if you're in the idle animation on your bottom half, we still wish you to rotate. So we now have a situation where it's not so easy to shake off the zombie, where it's going to constantly run to keep itself butted up against you, and it will be rotating you at all times. But of course, like I said, these are the decisions and the compromises that I've made. You feel free to do whatever you want with your animation. So you might decide that actually, when the zombie is in an idle state on the bottom half of the rig, I don't want it to rotate on the spot, and I do want it to have, you know, the root rotation, and that's fine too. But like I said, for me, I'm a little bit worried that it's going to be a little bit too easy to shake off zombies that are on you. But like I said, this could all change, because further on down the line, I'm going to put like a kind of quicksand effect on the player, so that when a zombie gets within melee range and so we start to feel its hands and its legs grabbing you, I'm going to kind of really limit how fast the player can move. So it's almost like the zombies have gotten hold of you and you can't get away too quickly. And I think that'll work really well as well, because without that, for let's say we had a great big crowd of zombies in front of us, it's going to be too easy just to push through them. We don't want that. So when you hit that crowd, it's like all of your speed is going to be sapped away. And I think that will be enough to terrify you enough that you're going to do your best not to spend any time in close quarters with any zombies. Okay, so the next thing we need to do now is we need to talk about animation curves, how they can be used to drive the animator, and how we can put some colliders on our zombies' limbs so that they can damage the player, but only at the correct times within the animation. We're going to write our damage trigger system. So the first thing we need to do is we need to add some triggers to the hostile parts of Zombie Jill's body, which for us is going to be her hands and her mouth. But we'll just work on the hands for now, okay? So if we drill down into Jill's AI entity game object, remember the hips is the root of a skeleton, so we want to drill down into there. The top half is going to be from the spine down, so if we open up the spine, spine 1, spine 2, close up the neck, we're not interested in the neck at the moment, and we'll work on her left shoulder first of all. So drill down into her left shoulder, her left arm, her left forearm, and there is her hand. Okay, so let me select Jill in the scene view so we can see what we're doing. Don't want to do this stuff blind, do we? So there you go. You can see there, that's the position of her hand bone. So what I'm going to do on her hand is I am going to add a trigger to it. It's going to be a sphere collider, and it's not going to be that big, okay? Definitely not. But it wants to be much bigger than the hand, you know. We want to give our zombie a fighting chance at hitting us. So we do want to really over exaggerate the proportions of her hand so that we don't insist that the interaction between the hand and our collider is so exact that the physical hand mesh has to kind of touch us, because we just don't have that sort of precision. So what I'm going to do is I'm going to move this along the Y a little bit. I'm just trying to kind of get her hand in the center of the sphere, and I might even open that up. I know that looks pretty big, but I might even open it up a little bit more to like 0.2, maybe 0.18. Yeah, I'll do that. Okay, and I need to make this a trigger. And of course what we're going to do is write a script that we add to this collider and other colliders on Jill that will detect when they penetrate the capsule collider of our player, and then we'll dish some damage out. But of course there's more to it than just that. We need to make sure that the hand isn't hostile the whole time, because if Zombie Jill is just walking and we just managed to brush up against her hand, this collider would cause us damage even though it wasn't in the middle of an attack animation. So that's what we're going to use animation curves for in a moment. But I'll add those later. First of all, we'll just check that the system works. Okay, so we've got this collider here. What layer does it need to be on? Well, it needs to be on a layer that is sensitive to our player's collider. So if I call up the physics manager, I think that's going to be our AI trigger layer. Remember, that's the same layer that her sensor trigger is on. It's sensitive to obviously the player and other threats, but we're only interested for now in it being sensitive to the player. Now if you really wanted to, you could create yet another layer called, like, I don't know, the damage system layer that was only sensitive to the player's capsule collider. But I'm going to use the AI trigger layer for this. You know, every now and then there might be other things that are registered with it, like a sound source or something like that, but all in all, we can just filter those out in the script that processes the trigger events. So that's what I'm going to do for now. I don't imagine it's going to cause too much of a performance issue. So making a note, I set the radius to 0.18 and the offset along the Y to 0.06. I'm going to add another one to the right hand. So I'm going to drill down into the right shoulder, right forearm, right hand. Oops, hang on a minute. Before I do that, I forgot to actually assign it to the AI entity, sorry, not the AI entity, what's wrong with me? The AI trigger layer. We don't want it to affect all the objects underneath it. We just want this object to be set to the AI trigger layer. So I'm just going to say no, only apply it to this object. So now let's go and do the same to the right hand. Before I forget, I'm going to set it to the AI trigger before I even add the trigger. And then I'm going to add a sphere collider, 0.18 and 0.06, wasn't it? Yeah, there you go. Okay, so next up we need to create one for the mouth, which is going to look a little bit weird, and I think I'm going to use a capsule collider in this because it really has to be quite exaggerated. So I'm going to add it to a head bone. Once again, I'm going to set her head to the AI trigger layer, and I'm going to add this time a capsule collider. Okay, well, All right then. What I'm trying to get is I'm trying to get something that looks a bit like an elephant's trunk coming out the front of her head. And I'm not quite sure. Yeah, so at the moment I need to set the direction of the Capsule Collider to probably the Z-axis. There you go. That's what I'm after. Still a bit big, isn't it, radius wise, so we'll make it smaller, something like that. It's also a bit long, isn't it, so we need to change the height maybe to something like that. Now we really want to make the length of this very over exaggerated, because in reality our zombie's mouth is not really going to get that close to the Capsule Collider of our character controller, and we can't really force it to get that close because, you know, if it did, it would start clipping the near clip plane of the camera. So we just need it to look like it's biting us, and then have a very long Capsule Collider that is actually sort of pointed down probably slightly and intersecting our Capsule Collider. Hang on, try to move the head bone. I definitely don't want to do that, folks. I need to move it, the center point, along the Z-axis in the Capsule Collider's inspector. I also need to set this as a trigger. I think that's about right. Let me just press play a minute and see what its natural resting place is when she's just sort of walking around. It could probably, yeah, I think it needs to come down a little bit, doesn't it? Probably. Actually, can I rotate it down? I can't rotate it down from here, can I? Which means I'm probably going to have to actually add this as a child object of the head. Bummer. Okay, let me remove that Capsule Collider. Let me reset the head bone to be on just the, was it on the default layer? Forgot what it was on. Yeah, the default layer. And then what I'm going to do is I'm going to create a new child object here. And I'm going to call this mouth trigger. Okay, and the mouth trigger is obviously at the same position it was before. It's at the origin of the head bone at the moment. So we'll set that to the AI trigger layer. We'll add a Capsule Collider to that. We'll set that to be aligned with the Z-axis. And then we'll reduce the radius to something like what it was before, something like that. And of course we will reduce the height. It's not too long. And then we'll move it so it's kind of sticking out of the head like so. But now, because it's a separate child object, I can rotate it about its X-axis. There you go, like so. Okay, let me just turn off maximization in the game view and press play and see what is kind of... I know that looks a bit rubbish, but I think that is kind of, apart from being a bit big, I think that is kind of the direction it needs to be kind of facing in. They'll probably move it up a little bit as well. So I'm going to move the whole game object up now, which we can do obviously because we moved our mouth trigger onto a separate game object. I'll make the height a little bit less again, something like 0.45 I think I'll set it to. Of course we won't really know for sure until we test. I might make it a little bit thicker, maybe 0.8 like so. There you go. When she looks at her, she looks a bit like Hannibal Lecter, doesn't she, with that mask on. Okay, so now what we need to do is we need to create a script that is going to be added to all of these triggers. And of course, if you had a kicking animation, you could also add a trigger to that as well. And we need to create a script that can be added to both the hands and the neck, or even the feet or the head, whatever bone is going to be hostile on your zombie, in a way that it can damage the player, and later on in a way that it can be multi-purpose, such that it can inform the animator whether it's the left hand, the right hand, or the mouth. Now at the moment we haven't actually got a way of damaging the player because our player has no concept of health. So for now, when this collision happens, we'll just output a little bit of text to the debug log saying a collision happened with the character, something like that. So we need to write this script, so I'm going to drill down into my Dead Earth folder, into my scripts folder, into my AI folder, and I am going to create a new C# script, and I'm going to call this AI damage trigger. And I'm going to open it up in MonoDevelop. And as per usual, we will delete the boilerplate stuff. Okay, so the first thing we'll do, just to check that the colliders are correctly colliding with our character controller, is we will create the onTriggerStay function, which is simply going to output some text while any of those triggers are in contact with the player. Of course, the onTriggerStay function doesn't take a collision structure, does it? It takes a collider, doesn't it? And all we'll do is we'll just say inside that, we'll just check if the collider we've been passed is a collider that belongs to the player. In other words, if it's the Capsule Collider of our character controller. So I will say if col, which is the collider that we've collided with, which of course will hopefully be the player. And then we'll get its game object so that we then can have access to its tag, and we will use its compare tag function and pass in player, because remember, our player object has the player tag, so we can simply check if it is the player by comparing its tag against the string player. And if it is, then we will just output some text that says player being damaged. Pretty simple stuff for now. Of course, we are going to develop this script a little bit more throughout the rest of this lesson, so it does something a bit more useful. Okay, so on the left hand limb, on our mouth trigger, and on our right hand limb, we will do add component, and we will add one of our AI damage trigger scripts to each one of those. Okay, so at the moment, if I walk up to Zombie Jill, actually what I'm going to do, guys, just so we can see what's going on, is I'm going to go to the lighting tab and I'm going to really ramp up the ambient lighting, okay, so that we're not constantly trying to see stuff through that little flashlight lens. And I'll call up the console window as well so we can see what's being output. So you can see at the moment all is well. Jill sees us, she comes up, and hopefully we'll start seeing some output. There you go. She's kind of attacking us, we're getting damaged as she's biting us. And every time her hands or her legs intersect our body collider, we can see that lots of damage is being done. The problem we've got at the moment is if I get out of the way of Jill, okay, hopefully she'll, she found me, and clear the console window, you'll see that at the moment those colliders that we've added to her, they're always hostile, even if she's not even attacking us anymore. If we just walked up against her, I'll try and do that now. If I brush up against, say, maybe her arm, there you go, I got loads of damage. And she wasn't even attacking me. So what we need to make sure is that those colliders only damage us when they're supposed to within the animation. So if I was to call up Zombie Jill's attack 1 animation on the attack layer, and then call up the inspector so that we can see the... Actually, if you double click on the attack, that will take you to the import inspector of the motion field, which is what I want. We can see that if we scrub through that animation, obviously Jill's hand should not be hostile until probably around about this point in the animation, and should probably only remain hostile until about that point in the animation. Right? So there's this little arch where she can do damage, but we definitely don't want to do damage there. Okay, so what we need to do is we need a way for each of our animations to tell the animator it's only at this particular point in time that this particular trigger, be it the left hand, the right hand, or the mouth, should be doing damage. And we're going to use animation curves on our animations to do that. And those animation curves are going to tell the animator via parameters. So we're going to have like a left hand parameter, a right hand parameter, and a mouth parameter. And those parameters are going to have their values driven by the curves on our animation. So let's say, for example, this animation, as you can see, is a right-handed attack. We will create a curve called right hand on this animation, which is going to be set to 0 here. But just as it goes into attack, it will set that right hand curve to 1. If we have a parameter in our animator that is also called right hand, then that curve is going to drive input into that same matching parameter in the animator, which basically means as that right hand goes into the hostile arc, the right hand parameter in our animator will be set to 1. So if we do this and we set it up correctly, you'll see that as we're doing a series of combination attacks, you'll see in the parameter list, the left hand will go from 0 to 1, then the right hand will go from 0 to 1, and then when the feeding animation is playing around about here, we'll see that the mouth parameter goes to 1, and we can see that the animator is correctly setting these parameters. So what good does that do us? Well, it does us quite a lot of good, because then our script can say, for example, I'm the left hand trigger, I'm intersecting the player. Now I need to check with the animator to see whether the left hand or right hand parameter is set to 1. If it's not, it means that although I'm colliding with the player, I shouldn't be doing any damage yet. But if it is set to 1, then it means that that curve is driving that parameter and telling us, yep, now it's fine to apply damage, and our script can apply that damage. Enough talk, let's see this in action. Okay, so what I'm going to do is I'm going to create 3 new parameters of type float. I'm going to call the first one left hand, I'm going to call the second one right hand, and I'm going to call the last one mouth. and they're all just going to be set to 0 by default. Okay, now what we're going to do is we're going to add curves on our animations with exactly those same names so that they can drive the hostile value into the matching parameter. Now, because we've got lots of attack animations, what I'm going to do for now is just basically fudge with this first transition, and I'm going to set its condition to say if it's greater than 0, if it's less than 99999, alright? And because this is the first transition, it means every single attack should be of this type, which means while we're testing this system, we can forget about adding curves to all these animations. We can just concentrate on attack 1 to see if it's working. So what I'm going to do now is I'm going to double click on the attack 1 state in the animator, which is going to call up the import inspector for our zombie attack 1 animation. And then what I'm going to do is I'm going to call up the preview window so I can see it pretty big, and I'm going to go to the curves drop down, and I'm going to click the plus sign now to add a curve. And I'm going to call this curve exactly the same name as the parameter in the animator that I want it to drive. And because this is a right-handed attack, I'm going to call this right hand. So now, when this animation is playing back, any values in this curve, which are currently 0, will be sent to the right-hand parameter in our animator. Let me just click apply there to say that I've made a change to that animation. But of course, at the moment, it's all set to 0. So what I need to do is I need to find a point where I want the hand to become active, about there, okay? And I'm going to click the little add keyframe sign. Then I'm going to move to where I want it to stop, about there, and then I'm going to add another little keyframe to the curve. I'm going to click apply just so I don't mess this up. Actually, what I'm going to do is I'm going to add another keyframe just before so that I don't have to have a curve up to where the hand becomes active. I want the curve to be sudden, not a curve at all. I want it to be a step. So what I'll do is I'll add one just before it, and I'll add another one just after where we're going to apply damage there. And then what I'm going to do is I'm going to seek along to that point in the animation where I want the hand to become active. And I'm just going to set that value to 1. Then I'm going to move along to the next one and set that to 1 as well. So you can see now that as our animation is playing, the right hand parameter in the animator will be 0 until this point is reached, and then it will be to 1. And the only reason I created these two additional keyframes is I need a way to be able to make this a very sudden step, or at least as sudden as possible. Otherwise, if I didn't have those keyframes, it would look like a curve like that. And that would be stupid, wouldn't it? Because the hand would be becoming gradually more hostile. So what I'm going to do is I'm just going to make sure I've got a definite step in there. Like so. Okay. Going to click apply. Okay, so if I press play now and leave the scene window active, keep your eye on the right hand parameter when Jill attacks me. We should see it sort of flicker to 1. Why is that pushing me up? Have I forgot to make that right-handed trigger? Oh my word, I have. It was a collider, not a trigger. What a silly man I am. Let me just check I've done that with the rest of them. God, do you know what? I do that all the time. And I'll be honest, it's starting to get me very, very annoyed. Okay, now watch the right hand in the animator, and hopefully we will see it go to 1. Actually, we won't because I haven't selected Jill. Hang on, let me select her AI entity. There you go, see it going to 1? It happens very quick, so blink and you'll miss it. But just at the right point when it attacks me, you can see it goes to 1. So what we need to do now is we need to go back to that script that's attached to each of our colliders, and we need to say, look, we only want this collider to do something. And in our case, that's going to be printing out text to the console window, but obviously later on, it's going to be applying damage to the player. When this collision has happened and the parameter that matches the game object that this trigger is on is set to 1 in the animator as well. So what we need a way of doing in this script is we need a way of letting ourselves know what parameter should be read back from the animator for this particular script. So what I'm going to do is I am going to create a serialized field. It's going to be a string, and I'm going to call this parameter. And I'll just set it to an empty string by default. So what I can do now is I can go back, I can select my body parts, and for my left hand damage trigger, I can say I want this to be reading the left hand parameter. And for our mouth trigger, that can read the mouth parameter. And for our right hand, that can read the right hand parameter from the animator. Okay? So now each of these scripts knows which parameter in the animator it should be listening to. So going back to our script, obviously we need to check that. So what we need to do is grab a reference to the animator. So I think what we'll do is in our start function, we'll cache all of this stuff, okay? And we'll make it more efficient rather than doing a search for the animator each frame. So in our start function, we'll need to grab a reference to the state machine. So actually I'll need a private internal variable for that to store it in. Because obviously the state machine is the thing that has the animator that we're after. Although this object is within the state machine hierarchy, obviously if it's on the right hand, the actual state machine script itself is way up, right at the very top of the hierarchy. So we're going to need to find that. So we'll create a new variable of type AI state machine. Now we won't make this AI zombie state machine because these damage trigger scripts can be used for all types of characters in our game, not just zombie state machines. I'll call that state machine, set it to null by default. Then in our start function we can say state machine equals, and we'll get the transform of our game object, which remember is the transform of either the hand or the mouth or whatever. And the reason I'm getting the transform is because the transform has a very useful property called root, which will take us right up to the very root of the game object, which is going to be OmniZombie Jill. And then once we've got her very top level object, we can then say get component in children. We know that there's only ever going to be one AI state machine in this hierarchy. Of course, what we're looking for is type AI state machine or one of its derivatives, like so. So now we have a state machine. We probably want to cache a reference to its animator, maybe. Why the heck not? So we'll create a new variable of type animator, and we'll call it animator. We'll set that to null. And then in our start function, we'll say if state machine doesn't equal null, then animator equals state machine dot animator. And what we probably want to do as well is we're going to keep having to check this parameter from the animator, either left hand, right hand, or mouth. So we probably want to hash that as well. So I'm going to create another private variable of type int, which I'm going to call parameter hash. Just set that to -1 by default. And in our start function, we will say parameter hash equals, and we'll use that static function from the animator class called string to hash, and we'll send in our parameter that we set via the inspector, like so. So that should allow us to efficiently call these things. I'll comment this stuff before I give it to you. Okay, guys? Okay, so now in our onTriggerEnter function, what we can say is, we better just check that we've got a state machine and an animator, haven't we? So I'll say if not animator, then return. Nothing we can do. Otherwise, we'll say if this is the player's game object and animator get float. Of course, we're going to pass in the parameter hash to get back the value of either left hand, right hand, or mouth, depending on what we set for this particular instance of the script. And we'll say if it's larger than, say, 0.9, then we're going to do the damage, but not before. Save that off, and then what I need to do is make sure that I have... I think I did it. Let me just check I've done it on the right hand. Yeah, I've added that script to the right hand as well and set the parameter, because we've only got that right-handed attack 1 animation playing. So what should happen now, okay, is we won't get as many attacks in our console window, and the reason we won't is because it's only going to do damage. There you go. Oh, parameter hash does not exist. What have I done? I must have spelt it wrong on the game object, I assume. Let's have a look. So check right hand is spelt right. Right hand, capital R, capital H. Mouth trigger, capital M in the parameter list. Left hand. Oh, there you go. I used a baby H. There you go. I bet that those errors will stop now. Once I've cleared the console. There you go. Let's try this. So you can see if I brush up against the zombie, notice she did no damage. Even though I brushed up against her colliders, it's not doing any damage to me because she's not yet in that damaged state. But if I stop now, there you go, player being damaged. Only as the hand strikes me. How cool is this? I love animation curves. They are just so awesome. So of course all we're going to do is we're going to, in our AI damage trigger script, what we'll do is we'll allow you to specify how much damage per second this particular trigger does. So So we could say that the mouth does more damage, and in Dead Earth it will also be the mouth that actually infects you as well. So this is pretty cool stuff. So what we need to do now, right, it's a bit long-winded, but I should probably show it anyway, is we need to add curves to all of these animations, all right? And I am going to record myself doing this, just because if any of you are following along exactly and you have the same animations as me, then it's going to be, you know, if you get into any trouble, you're going to be able to refer back to this. So looking at my first transition, remember we altered the greater and less than conditions, and we said less than 9999, and that was because we only wanted attack 1 to be triggered while we were testing our system. So I'm going to set that back to 21, and then what we're going to do is double click on each of these states, and we're going to set the curves for each of these animations. That's going to be quite cool because some of these are combos. So the first animation we're going to work on in this little block is attack 2, which is the feeding animation. So we need to add a new curve to this animation, which is going to animate the mouth parameter in our animator. So I'm going to click the plus sign to add a new curve, and of course I need to make sure that I call this mouth, okay? Very, very important. It needs to match the name of its parameter in the animator list. Okay, so I'm going to move along to the bit where I think, where I think the mouth needs to become hostile. So it's not there. In fact, I think what I'm going to do actually is I'm going to add 2 more curves to this. I think I'm going to make, you'll notice that as she goes to bite you, she also kind of grabs you. And I think I'm going to make that grabbing motion also damage you. So what I'm going to do is I'm going to add, well, I'll work with the mouth first of all, okay? So she's not biting, she's not biting. She's biting now. So I'm going to add a keyframe there, one just the frame after it, like so that we can get that nice step in the curve. So I added 2 keyframes there, kind of very close to each other, but just like 1 frame apart. She's biting, 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 and now she's breaking away. Let's get to the point where she's no longer biting, about there. And we'll add another keyframe there, and add another keyframe there. So now when I open this up now, what I can do is I can see I have the kind of all the points that I need to set for this. So let me now step through them one at a time. So the first one doesn't need to be modified. The next one doesn't need to be modified, but the next one, the next frame on, does need to be modified. We need to set this up to 1, folks. Then I need to step along to the next one, set that up to 1 as well. And there you go, I now have my perfect mouth curve for this animation. Dun, dun, dun. You can see right while it's up the top is where it's going to be doing some serious damage and affecting us. But like I said, the hands also grab the player in this animation, so I think I'm going to make this a kind of a combo damage move, so the hands even damage you when they grab you. So I'm going to add 2 more curves, and the first one I'm going to call left hand, and the next one I'm going to call right hand. Remember, they must match exactly with capitalization, their namesake in the parameter list, okay? So I'm going to work on the left hand curve first. Right about there, the left hand grabs you. So we'll add a keyframe there, scrub along 1 frame with the cursor keys, add another frame there, and the hands keep grabbing onto you till about the left hand comes off instantly down there. So the left hand comes off a little sooner. So we'll add 1 more there. 1 more there, and now I'll do the right hand. So the right hand comes in kind of the same time as the left hand, really, doesn't it? About there. So I'll add a keyframe there, scrub along 1 frame in the timeline, add a keyframe there. The right hand stays on a little bit longer, I believe. A little bit, so we'll bring it off there. Just to show how flexible this system is with combos and stuff like that. Okay, so what I need to do now is I just need to step through the points on the curve and set them to 1 where they should be 1. So we'll set this one to 1 here. When the left hand starts to become hostile, we'll move on to the next one, set that to 1 here. Perfect, and then we'll move down to the right hand and set the next one to 1 as well. So now we have a biting maneuver that will be really deadly because both the left hand and the right hand damage triggers are going to be dealing damage. So too will the mouth. So that's, no one's going to want to get bit in this game, that's for sure. So next we'll go down to animation 3. What's this one? So right-handed blow. So pretty easy stuff this. You have to call this right hand. Scroll along to where it becomes hostile, which is probably about there. Add a keyframe. Scrub along one frame, add another keyframe, and then track along to about there. Let's put the ones in where they need to be. And now we'll go down to attack 4. Remembering to apply our changes. And what's attack 4? That's kind of interesting, isn't it? Because he kind of grabs you with the right hand. Should that right hand be doing any damage when it does that? Do you know what? I think it should. How? Why not? So this has got a left hand and a right hand damage. So we'll add 2 curves. Call the first one left hand. Call the second one right hand. And I'll work on the left hand first, which doesn't really become active until about there. So I'll add a keyframe there. We'll move along one frame. Add another keyframe there. And as it comes down there, we'll make it non-active again. Add another 2 keyframes there. And for the right hand, what did we say we were going to do? We were just going to sort of make it a little bit hostile when it grabs you at the beginning. So kind of about there. Probably till about there. Yeah, the right hand's kind of grabbing you for quite a long time, isn't it? Okay, so now we have our markers in place. We just need to set them to their correct values, right? So we'll start with the left one first of all. And I don't really need to narrate this, guys, do I? I mean, you can just see what I'm doing, but I don't like having the dead air. So I should probably play some background music while I do this. I could just say, hey, here's one that I did earlier. But I don't know, you might think that's a cop-out. Okay, so next up, attack 5. This is an interesting one because, as you can see, it's got like it's a combo. So it does a right slap, a right backhand bitch slap, a double parry with both hands, and then another sort of bitch slap with the right hand. So there's actually this one animation does like 4 blows. Sorry, left hand, right hand. And then what we need to do, folks, is we need to step through this puppy and find all the bits where that right hand is going to sort of bitch slap us. So we'll say about there. To about there. Then we'll say about, it's coming back about there. So put it in there. And we'll let that be hostile till it's all the way back, like so. And then we do the double parry here. It probably could start a little bit earlier than that. Like so. Down to about there, and then we'll stop it being hostile there. Being a bit generous to the zombie there. I don't think it'd be hostile down there anymore. And then he does that one big back slap. That goes till about there. Well, probably a little bit less than that, about there. It's not anymore, is there? No. Okay, so what we need to do now is just step through there and set all the ones where they need to be. So, one there. One there. And there you go. So just as you would imagine to see now, the curve for the right hand basically has that little peak in it every time it should be doing this damage. So we've just got one place now where we need to identify where the left hand is doing damage, which is it's about there, isn't it? So we'll add a keyframe in there, move it along a frame or two, add another keyframe, yeah, down to about there. It's kind of nice because the fact that both of those hands have triggers on them, and both of them will be doing damage independently to the player. We don't have to do anything special to say the two-handed attack does twice as much damage. It would just naturally happen by the fact that two colliders are generating sort of two collision responses. Okay, finally guys, I've decided that I'm not going to show you the rest of them, alright? What I'll do is I'll pause the video and I'll just finish off the last three and then just show you what the curves look like. Okay, because this is boring for you, I'm sure. You get the idea now. Okay guys, so I'm back. So let me show you the curves that I set up for the remaining three attack animations. Attack 6, Attack 7 and Attack 8. So I'm going to double click to bring up Attack 6. And there you can see its curves. And hang on, let me just scrub through it. So there you can see right hand. Oh, look at that. And it follows through with the left hand straight afterwards. And then kind of in reverse. Left hand and then right hand. Here is the curve for Attack 7. Bosh with the right hand. Bosh with the left hand. Bosh with the left hand again. And Bosh with the right hand. And of course, if you look at the values in the curve editor, you can see at the moment I'm just going between 0 and 1 for all of these curves. Although I may change that a little bit later on. But for now, let's just assume that 1 in the curve means damage is being done and 0 means it's not. And finally, Attack 8, which was the headbutt. And I'm just going to reuse the mouth parameter for this because it's attached to the head, so it should do fine. So you can see just as the head starts to come forward, about there I decide to make it hostile. And that's all of the curves set up for all of the animations in the attack layer. So what I'm going to do now is go back to our AI damage trigger script, and what we're going to do is we're going to add a new parameter which I'm going to call blood particles burst amount, much like we used in the feeding state, but we're going to allow that parameter to specify how many particles should be emitted in each physics update that we find that we are colliding with the player. So in other words, every time we get into the onTriggerStay function and we find that we do have a collision with the player and damage should be getting done by this trigger, then we're going to emit some particles. So I think for now I'll go a little bit over the top and I'll set the blood particles burst amount to 10. Now that might not sound much, but do bear in mind that if, for example, the trigger was in contact with the player for an entire second, that would be 50 bursts of 10, 500 particles. So it's quite a lot. We'll probably want to dial that down a little bit. I should also say that at the moment, because we haven't really put some of the management stuff in place for our FPS controller, that when it comes to the location of where I'm going to emit those blood particles, for now I'm just going to fudge it and do something a little bit temporary. Okay, so inside our onTriggerStay function now, what I'm going to do is reuse our blood particle system, which we used for our feeding state. And remember, this is a particle system that all zombies in the level can use because it's actually stored in our game scene manager. So in order to emit blood particles from it, we can simply just contact the game scene manager, get a reference to this particle system, and then we can move it into the position that we want it just before emitting the particles. So let's have a look what this code looks like. So first of all, I better check that I have a game scene manager instance and that the game scene manager instance has a valid reference to a particle system. And then what I'll do is I'll cache a reference locally to that particle system so I don't have to keep doing game scene manager .instance .blood particles every time I want to set one of its properties. And then what we're going to do is, much like we did in the feeding state, we're going to set the position and the rotation of that particle system just prior to emitting the particles. So because I don't have anywhere on my FPS controller rig yet to actually mount the blood particles, I don't have a mount there yet. At the moment I'm just going to do something temporary so that we can definitely see the blood particles. So I'm going to set the location of the particle system to the position of this trigger. In other words, if this was the left hand trigger, then that would be at the location of the left hand bone. And for the rotation, I'm just going to set it to the same rotation as the camera. This will just kind of make sure that the blood is emitted kind of forward, it splats forward. But like I said, we don't really want the rotation always being taken from the camera because the attack might be happening from behind. And then just like we did in the feeding state, we set the particle system's simulation space to world. Remember, lots of zombies in the level may all be using this same emitter, so as it's being moved around the level, we don't want any particles that we emit in this script to move and keep their positions relative to the position of the emitter. So once these particles are emitted, forget about the location of the emitter. These things just need to play out in the world. And then finally, we will tell the particle system to emit by our blood particles burst amount that we set in this inspector variable. I save that off now and then go back to the editor, check I haven't got any errors, maximize the game window. We should see we're going to get some blood squirting up when the zombie hits us. So hey, hello dude. He's coming to get us. Whoa, missed that a little bit, but we could see some of it, couldn't we? So there you go, there's some blood coming up here. Okay, it doesn't look too good at the moment. Actually, those ones look quite good. But you can see it's probably a bit low at the moment, and when we actually have a mount for the blood on our FPS controller rig, we'll be able to have a little bit of control, because at the moment it's all happening kind of beneath the camera. And the reason why I'm not really changing this too much at the moment is because I'm not totally sure that I'm not going to do some IK a little bit later on. And when these zombie attacks are happening, I may try and move the final location of the fists, for example, if they're attacking, to the player's head, the camera's position. So it might look like, you know, they're kind of hitting you in the face a little bit more. But at the moment, we don't really have any of our FPS controller stuff registered with the Global Game Scene Manager. So it's a little bit hard for all of our other scripts to get access to them. So that's why at the moment I'm just using some temporary stuff. So let's just see it again. Check it's all working. Bosh. Oh, that was the headbutt. You can see the actual blood actually happened with that headbutt behind the zombie's head. So we need to, I think if we look down, we'll be able to see all this stuff a lot better. Yeah, there you go. Like you said, it's all happening beneath us at the moment. Okay, so I think I'm going to leave it there for now. And when we come back in the next lesson, we're going to continue to flesh out some of this temporary stuff that we've got in place. But most of the lesson is going to be dedicated to the blood effect that's going to happen on the camera lens. And I'm going to show you how I made the texture and the shader to basically create this effect. What you're looking at here is one of the scenes from the production copy of Dead Earth. And we're going to create a blood effect that kind of, as you get hit, and the more you get hit, the more the blood kind of covers up the camera lens. And the way that this script is going to work is when the zombie hits you, depending on how much damage you've got or how much your health drops, you're going to kind of see some blood on the screen. And over time, as you sort of begin to sort of heal, that blood's going to wear off. But you can see it goes from very bloody when you're nearly dead to just having little bits on the screen. So that's a pretty cool effect. So thanks for listening, guys. I will see you next time. Bye bye now.